Welcome to this lecture on process control. We are doing Laplace transform, chapter 2, Laplace transform. This is part 21. We are seeing forcing functions. We have seen about 3 forcing functions in the last lectures. In this, we'll see another forcing function. Before we go into that, I request you to kindly subscribe to this channel. Those who are not subscribed, please subscribe to this channel so that you get notification of the upcoming lectures. Please share it to your friends also. Well, now let's go into the lecture. And in this class, you are going to see what is known as a ramp function. A ramp function is also known as a linear function. These forcing functions, if you recall, they are used to model the behavior of the input variables in a process. We need mathematical equations for the variations of input variables for a process. So these forcing functions are used to represent the variations in the input signals to the process. Well, now ramp function. What is a ramp function? A function whose value changes at a constant rate. Changes at a constant rate with respect to time is known as ramp function. A function whose value changes at a constant rate. Changes at a constant rate is known as a ramp function or linear function. Quite often some variables, previously like we have seen step function or pulse function or impulse functions, they are all sudden or quick changes. But whereas this linear function represents when the variables undergo a gradual change. The variables undergo a gradual change slowly with respect to time, but at the same time, the variation is at a constant rate with respect to time. So in such cases, the variation can be represented by a ramp function. If you plot, the plot of this will look linear, straight line. If something changes at a constant rate, the plot will be a linear or straight line. If we make a sketch of this function, it is going to look linear, straight line as shown here. So it's a straight line, the slope is m. Slope represents the rate of change of this equation, the rate of change of this function. And for a straight line, the slope is constant. So the rate of change or the slope m is constant. So the function changes at a constant rate m. So the equation for this will be f of t will be equal to 0 for t less than 0. Of course, we are not concerned with that for the period t less than 0. We are concerned with the period t greater than 0. For t greater than 0, f of t equal to m into t. Equation of a straight line is m into t. So f of t equal to m into t. So this equation, this is a mathematical equation to represent this ramp function. F of t equal to m into t. Simple equation, f of t equal to m into t. F of t equal to m into t, and m represents the rate of change or the slope in the figure. M is rate of change or the slope. That is this. So this is m. So this is the equation for a ramp input, and the Laplace transform of this Laplace transform of f of t equal to what? Laplace transform of t is 1 by s square. So mt is m by s square. So this is the Laplace transform of f of t. So this is about ramp function or linear function. It's a simple function. I hope you had understood this. We'll come with another forcing function in the next lecture. See you till then.